So before we go on, Tom noticed that I messed one of these examples up. So look back at number 3. Do you see how there was an x in both terms? We were supposed to factor out an x also. So we got to go back and fix that one. So we'll go back and fix number 3. So, yeah, there was an x in both terms. So you also have to have an x as part of your greatest common factor. And then what's the lowest power that the x appears to? Yep. The lowest power that x appears to in either term is the first power. All right, and then we just got to fill the parentheses in again. So we got to do negative 2x times what would give you negative 14x. Yeah, just 7. So that'd be just 7. And then negative 2x times what would give you negative 12x squared. Or I could write it again with that division step that I showed you guys. What goes in right here would be that second term, negative 12x squared, divided by the greatest common factor, which was negative 2x. Yep, it should be a positive 6x. Since it's a positive 6x, we write plus 6x. Again, if you wanted to check it, you could do a negative 2x times a positive 6x, and that should give you a negative 12x squared, which it does. All right, so we fixed that one. So let's go down to number, what are we on, 6? So let's look at 6. Now 6, this looks a little bit different. What you have here is you still have 2 terms, okay? The 2 terms are right here and right here. They are separated by this addition symbol right here. So what's in common in those 2 terms? Yeah, the quantity in the parentheses, right? Both of those terms have x plus 2 in them. So that's going to be your greatest common factor. So you're going to factor out in front of x plus 2. And then from there, you basically write what's left over. Now, let me move this down a little bit so you can see. So what you have in common is that quantity x plus 2. Well, again, what you would do then to figure out what would go in these other parentheses is you would divide that first term by the common factor, which would be x plus 2, right? What would be left over then? Just the 5. And then same thing here. You would divide the second term by that greatest common factor of x plus 2. And all you'd get was those would cancel out, and you just get plus 3x, a positive 3x. Now, you wouldn't write that like that, but just so you can see what you were doing. Oops, I erased part of it. That's supposed to say 5 plus 3x. Like that. So that's your answer. The quantity x plus 2 times the quantity 5 plus 3x. Let's try 7. So in 7, the 2 terms are separated by this addition right here. And there is a positive 1 right there, out in front of that quantity b squared plus 1 on the right. So then what do you got in common? I mean, here's your 2 terms, right? One term is this one, the other one is this one. So what's in common? I mean, what's in there? B squared plus 1, yeah. So the quantity b squared plus 1, that's in common. So that's your greatest common factor. And then what's left over if you divide that into each of those terms? Well, if you divide this term by b squared plus 1, all you get left with is what? What's left over? You've already factored the b squared plus 1 out in front. So what's left over, guys? Just negative 2b. So negative 2b. And then just 1, right? Positive 1. So plus 1. All right. Then number 8. Are the quantities in the parentheses the same? The one on the left is z squared minus 7. The one on the right is 2z cubed plus 1. Are they the same? No. So you cannot use the quantity in parentheses as your greatest common factor. And then 4 and 9, those don't have a greatest common factor other than 1. So this one is prime. So you just leave it like it is. So you cannot factor that any further. All right. So then there's going to be one more step on, what do we got, 10, 11, 9, 10, and 11? So this is called factor by grouping. So this is going to look pretty much like the examples we did in 6 and 7, but there's one step we got to do first. So what we're going to do is we're going to look at these first two terms. What's in common in those two terms? What's the largest number that divides evenly into 6 and 4? That's a 2. And is there an h in both terms? Yes. What's the lowest power it appears to? A 3. So that's going to be our greatest common factor for the first two terms, is going to be 2h to the third power. So then we're going to fill in these parentheses. So then we're going to say 2h to the third power times what would give us 6h to the fourth power? Or just do it one step at a time. 2 times what would give us 6? That would be a 3. And then h cubed, hold on. H cubed times what would give us h to the fourth power? Good. Ethan, that's good. So just h. And then we would say 2 times what would give us negative 4?
Negative 2.
It's going to be a negative 2. Good. And that's all we need on that one, right? Just negative 2. If you check that, if you do 2h cubed times negative 2, you get negative 4h cubed. So you're good on that part. Now what we're going to do then is now we're going to factor the second two terms. So these two terms. What's in common? What's the greatest number that divides evenly into 12 and negative 8?
4.
Yeah, 4. I should just say 12 and 8. So that'd be a positive 4. And then we're going to fill in these parentheses. So we really are doing the distributive property backwards here. So now we're going to say 4 times what would give us 12h? Good. That's good, Tom. 3h. And then we're going to say positive 4 times what would give us negative 8? Negative 2. Good. Now, do you see that it looks exactly like problems 6 and 7? You got two terms here, right? You have this term and you have this term. What do they have in common? Yeah. The quantity in parentheses, 3h minus 2. So you pull out a 3h minus 2. And then what's left over?
2h cubed and 4.
2h cubed and a positive 4, right? So that's it for that one. All right. What do we got? 2 more to go? So number 10. Do the same thing again. These two terms, what's the largest number that divides evenly? Yeah, let me ask, we got the buzzer there, got us. So what's the largest number that divides evenly into 5 and 15?
5y cubed.
Just 5, right? And then is there a y in both terms? Yes. What's the lowest power that it appears to? A 3, right? Then we're going to say 5y cubed times what would give us 5y to the 4th? You guys got that? If you're not sure, remember you can take that first term, 5y to the 4th, and you can divide it by your greatest common factor, which is 5y to the 3rd. What do you get? What do we need in that spot right there, guys? Come on, we're almost done. We're doing 5y cubed times what would give us 5y to the 4th? Yeah, just one y. So that should just be y, that's all. That's just one y. All right, and then we got to do 5y to the 3rd times what would give us negative 15y cubed? What's that? What kind of 3? Good. If A, that's good, negative 3. All right. And then out of these second two terms then, out of these two, what do they have in common? Just y, right? They have a y in both terms. The lowest power that it appears to is the first power. So the common factor for that one is going to be, for those two terms, is going to be a positive y to the first. And then we're going to say y to the first times what would give us y to the second? Guys, y times what gives us y to the second? What's that, Ethan? Yeah, just y. So that should just be one y right there. And then y to the first times what would give us negative 3y? What's that?
Just negative 3?
Yeah, just negative 3. It's good, Tom. So just negative 3. Remember, you can always check these, right? You could do positive y to the first times the negative 3, and you should get this term right here, negative 3y. But the other thing I want to point out right now before we wrap this up is that this method is working. Do you guys see that these things have to match? Those have to be the same. That quantity y minus 3 on the left there, you also have to get, in order for this method to work, you got to get the quantity y minus 3 in that term on the right. So those have to match. Okay, so then that's what they have in common, the greatest common factor between these two terms. Again, here's the first term, here's the second term. The greatest common factor is the quantity y minus 3. What's left over? If you divide y minus 3 into both of those terms, what's left over, guys? Go on, 5y to the 3rd, and what else? Yeah, plus y to the 1st, right? All right, so all you're doing is, once you factor out that greatest common factor of y minus 3, then this second binomial right here, that second binomial factor is just going to be 5y cubed and plus y. All right, last one. So again, first two terms. What's the greatest common factor? The largest number that divides evenly into 2 and 12? 2. Is there x in both terms? Yes. What's the lowest power it appears to? The second power, good. Now, do you see why that's the common factor? Look at this term right here would have an x times an x, right? This term on the left here, the first term, that would have an x times an x times an x. Well, what do they have in common? Well, this one has an x times x, and this one also has an x times x. That's why that variable part of the greatest common factor is x to the second power. All right, then we still got to fill in these parentheses then. So then we say 2x squared times what would give us 2x cubed? Just x. That's good, Tom. And then we say 2x squared times what would give us negative 12x squared? And again, if you're not sure, all you do is you take that second term, negative 12x squared, and you divide it by your greatest common factor, which was 2x squared. What do you get? You get negative 6. Good. And that should work, right? All right, well, if this method's going to work, then when we factor these next two terms, we should also get that quantity x minus 6. So let's try it. So we're going to do these two terms. What's the greatest common factor of, or the largest number that divides evenly into 3 and 18? 3. Now, here's the trick. Do we need to use a positive 3 or negative 3? You got to watch this part. Yeah, we need to use a negative 3, so watch what happens. So we're going to factor out a negative 3 and then fill this in. So we're going to say negative 3 times what would give us negative 3x? Just x, right? And then we're going to say negative 3 times what will give us positive 18? What's that, Ethan? It's got to be a negative 6. Do you guys see that these match now? This one matches with that one. That's got to happen or you can't use this method. This is called factor by grouping. And you use this factor by grouping when you have 4 terms, okay? The original problem has, again, terms are separated by addition and subtraction. So you have 1, 2, 3, 4 terms. That's why you try the factor by grouping. Now notice if you guys would have not taken out a negative 3, if you would have factored out a positive 3 right here, it wouldn't work, right? Because now you'd have a negative x plus 6. And if you did that, well then now this and this, they don't match, right? Negative x plus 6 is not the same thing as x minus 6. So let me rewrite it and fix it the way it's supposed to be again. So what is it again? It's supposed to be a negative 3. And then x minus 6. So again, now these match. So since those quantities in the parentheses match, that is our greatest common factor for this term and this term. So we factor out the greatest common factor of x minus 6. What's left over? 2x squared and minus 3, right? Does it kind of make sense? So what was left over again was the 2x squared and the minus 3. So that goes in the other set of parentheses. Now, again, you could kind of see that this works because what you're doing now is you could say, okay, if I take this whole thing and distribute it onto here, I'll get this first term right here. And if I take that x minus 6 and I distribute it onto this second term over here, that'll give me the second term that I have right here. But again, this was our final answer right there. And that's it. That's all of them, right? All right.